Good day, everybody. I hope everyone is having a fine day. Today we will be talking about t-tests for uncorrelated means. Just sit back, relax, and enjoy the video. The formula we'll be using is t is equal to the mean of the first group subtracted by the mean of the second group divided by the square root of the variance of the first group divided by the population of the first group plus the variance of the second group divided by the population of the second group. The question is, how do we find the variance of both groups? Well, for the variance of the first group, that is equal to the summation of x sub 1 minus the mean of x sub 1 squared divided by n sub 1 minus 1. For the variance of the second group, that is equal to the summation of x sub 2 subtracted by the mean of x sub 2 squared divided by n sub 2 minus 1.
Find the following: the t-value, variance of the first group, variance of the second group, and the tabular value. Also state the null hypothesis and your decision. Now we have to complete the table. In order to complete the table, you must do these following steps. First, get the mean of x sub 1 and x sub 2. To get the mean of x sub 1 and x sub 2, add all the numbers in traditional or x sub 1 and simulation or x sub 2. Then divide it by n. The summation of x sub 1 is 29.9 and the summation of x sub 2 or simulation is 31.4. Next, subtract x sub 1 to mean sub 1 and x sub 2 to mean sub 2 individually. Next, look for x sub 1 minus mean sub 1 squared and x sub 2 minus mean sub 2 squared. Then look for its summation. To get the summation of x sub 1 minus mean sub 1 squared and x sub 2 minus mean sub 2 squared, simply add all of the numbers in its column. Now, the summation of x sub 1 minus mean sub 1 squared is equal to 616.9 and the summation of x sub 2 minus mean sub 2 squared is equal to 830.4.
Now we are going to state the null hypothesis. There is no significant difference between traditional and simulation.
Now that we finally found the values of summation of x sub 1 minus mean sub 1 squared and summation of x sub 2 minus mean sub 2 squared, we can now proceed to the next step, finding the t-value, variance of the first group, and variance of the second group. To get the variance of the first group and the variance of the second group, simply use the formula. Now, just substitute it. For the variance of the first group, it will be 616.9 over 10 minus 1. Variance of the first group is equal to 68.54. For the variance of the second group is equal to 830.4 over 10 minus 1. Variance of the second group is equal to 92.27. Now, let's look for the t-value. Simply use the formula for the t-value. At this moment on, let's just substitute. For the substitution, it will be 29.9 minus 31.4 over the square root of 68.54 divided by 10 plus 92.27 divided by 10. This will give you a result of negative 0.37. Since it's a negative value, we can't use this. We must use the absolute value. The absolute value is simply the positive value of any answer. So in this instance, the t-value is equal to 0.37. After this, we need to know the value of the degrees of freedom and the tabular value. For the tabular value, we will just show it to you at the end of the video. For the degrees of freedom, it is equal to the population of the first group and the population of the second group added minus 2. For the degrees of freedom, it will be 10 plus 10 minus 2. the degrees of freedom is equal to 18. Your alpha value is equal to 1% since it is stated at 1%. So now, we must compare the computed value and the tabular value. Your computed value is equal to t, and your tabular value can be seen at the table of values. If your computed value is less than the tabular value, reject the null hypothesis. If your computed value is greater than the tabular value, accept the null hypothesis.
The decision is the HO is accepted because the computed value is lower than the tabular value. There is no significant difference between traditional and simulation.
Here is an example with an unequal number of population samples. No changes needed to be made. Simply find the following again: the t-value, variance of the first group, variance of the second group, the tabular value, and state the null hypothesis and your decision. Now let's complete the table. Get the summation of x sub 1 and x sub 2. The summation of x sub 1 is equal to 596. The summation of x sub 2 is equal to 627. Get mean sub 1 and mean sub 2. Mean sub 1 is equal to 59.6 and mean sub 2 is equal to 78.38. Now complete rest of the table. Complete x sub 1 minus mean sub 1 and x sub 2 minus mean sub 2. After that, get x sub 1 minus mean sub 1 squared and x sub 2 minus mean sub 2 squared. The summation of x sub 1 minus mean sub 1 squared is equal to 1598.4, and the summation of x sub 2 minus mean sub 2 squared is equal to 517.84.
The null hypothesis is there is no significant difference between engineering and computer science.
Now that we finally found the values of summation of x sub 1 minus mean sub 1 squared and summation of x sub 2 minus mean sub 2 squared, we can do the other steps. Variance of the first group is equal to 1598.64 over 10 minus 1. And variance of the second group is equal to 517.84 divided by 8 minus 1. Variance of the first group is equal to 177.6, and variance of the second group is equal to 73.98. Now let's look for the t-value. To look for the t-value, simply use the formula for the t-value. Now let's substitute. The t-value is equal to 59.61 minus 78.38 over the square root of 177.6 divided by 10 plus 73.98 divided by 8. The t-value will be negative 3.61. Since this is a negative value, we need to use the absolute value. The absolute value is equal to 3.61. After this, we need to know the value of the degrees of freedom and the tabular value. Degrees of freedom is equal to n1 plus n2 minus 2, or 10 plus 8 minus 2. Degrees of freedom is equal to 16. Our significance level is at 1%, and the tabular value is 2.583. Take note, computed value is equal to your t. Computed value, if the computed value is less than the tabular value, reject the null hypothesis. And if the computed value is greater than the tabular value, accept the null hypothesis.
The decision is the null hypothesis is rejected because the computed value is higher than the tabular value. There is a significant difference between engineering and computer science.
Now, our last example. In this example, we have the same number of population samples. Find the following: the t-value, variance of the first group, variance of the second group, the tabular value, and state the null hypothesis and your decision. Now let's complete the table. To complete the table, simply redo the steps you used in the previous two examples. Get the summation of x sub 1 and x sub 2. Summation of x sub 1 is equal to 407 and summation of x sub 2 is 377. Get the mean of x. Get mean 1 and mean 2. Means of 1 is equal to 45.22 and means of 2 is equal to 41.89. Now let's complete the table. Complete x sub 1 minus means of 1 and x sub 2 minus means of 2. Now, get the squares of those results. Get x sub 1 minus means of 1 squared and x sub 2 minus means of 2 squared. Get the summation of x sub 1 minus means of 1 squared and x sub 2 minus means of 2 squared. Summation of x sub 1 minus means of 1 squared is equal to 4,115.57 and summation of x sub 2 minus means of 2 is equal to 164.87.
Now state the null hypothesis. There is no significant difference between AOE and ABC.
Now that we have the values of the summation of x sub 1 minus means of 1 squared and the summation of x sub 2 minus means of 2 squared, we can now proceed to the next step, finding the t-value, v1 and v2. v1 is equal to 514.45 and v2 is equal to 20.61. Now let's get the t-value. To get the t-value, just use the formula for the t-value. T-value is equal to 45.22 minus 41.89 over the square root of 514.45 divided by 9 plus 20.61 divided by 9. The t-value this time is a positive, so just take the value as it is. T-value is equal to 0.043. Now let's get the degrees of freedom and the tabular value. Degrees of freedom is equal to n1 plus n2 minus 2, which is 9 plus 9 minus 2 is equal to 16. Significance level is at 5%. Our tabular value is at 1.746. Take note, when computed value is less than tabular value, reject the null hypothesis. And when computed value is greater than tabular value, accept the null hypothesis.
Decision: the null hypothesis is accepted because the computed value is lower than the tabular value. There is no significant difference between AOE and ABC.
Here is a table of tabular values. There are two tabular values. One is for the significance level of 1% and for 5%. Note, if the significance level is not stated, it is automatically 5%. To find the specific tabular value in the table, we use the degrees of freedom in the significance level. Example, the degree of freedom is 4 and the significance level is 1% or 0.01. To find that tabular value, you must first go down to the row of 4 under degree of freedom and go over to the column of 0.01 for 1%.